Okay, I'm going to get you started in modeling this bridge in Fusion real quick. We want to show the data panel up here in the upper left. Create a new project. Do that right here. And I've created Bridge 2023. I'll just use that. So double click, and I started one here. We'll do a new one. This lets you add collaborators, people to this project, your partner, and all. So you want to create a project folder. Okay, so we are going to open our assembly from the other. This is the assembly method. We're going to try to get assembly in here from Onshape. So let's bring Onshape in. There's our bridge. You're going to go down here, right click on the bridge assembly, export that document as a step file, and download. You don't need to change any settings. And it's being prepared for export. It should show up down at the bottom once it's, there we go. So there it is. Let's go into Fusion, and let's just open that. This will create a new file. Open from my computer, and there it is. Okay, now that should bring it in like this. Okay, now first thing you need to do, you probably have steel set as your default material. So this is going to show up as steel. So we want to change it to MDF. That's kind of our modeling material. So one thing you can do here, let's save this project into that folder first. So click File, Save, and notice it's saying Bridge 2023, and we'll just call it Bridge Assembly. Okay, I've got my new file here. If my partner wants to access it, they can. So now we want to go and get all these parts. These are all the parts of your assembly. When we click on the first one, hold down Shift, scroll down to the last one. Okay, and that should have them all selected. You want to make sure the whole bridge is blue, and then right-click on any of the parts and choose Physical Material. And that's going to bring up this. Mine is set for MDF already. All you need to do is go down to it's a wood in the wood category, and keep scrolling down until you find medium density fiberboard. Drag that and drop it onto your bridge. Okay. If you have steel there, you can try right-clicking and unassign and delete steel. But it should, if you click Select Object Apply To, it should show up. It's a little glitchy, but go by what's in this list, and that's what you got. It should all be blue over here. If it's all blue in this list, it's good. I don't know why sometimes I'm not showing up there. So you can close that. That's all you need to do for setup, and change this to simulation. I'm going to close my data panel over here. The mouse controls are wheel, of course, to zoom, hold wheel to pan, hold down Shift and wheel to orbit. You'll want to use these. That is, hold wheel to pan, Shift wheel to orbit. Okay. And now we're going to go into simulation. Okay, we're going to do a static stress. We are going to do static stress and modal frequencies. Those are the two studies we're going to do. We'll start with static stress. This is a similar study to the 2D study, similar to what you did in ENGILab, except for it'll be 3D. It should be very similar to what you saw there. So we're going to create the study. There's our bridge. We've got to add a few things. We should verify that our study materials are medium density fiberboard, which they are, and we have no load cases yet, so we've got to add our loads. You don't need to use gravity. It's very insignificant in this case. You can turn it on if you like, but I don't think it's going to change your results all that much. So we've got constraints, so let's add some constraints. Fixed constraint should be good enough for our purposes to see what's going on. We can apply a fixed constraint, which fixes this in space, to 2 of the straws. If you want to get more, you can add the outer faces. That's going to, hold down Shift to orbit, hold down wheel, and it's up to you. I think it works just fine with just the straws, but pretty much those are all fixed by the bolts. So now you can see over here we've got fixed constraints. And now we're going to add loads. structural loads, it's going to be a force, and our targets, this one does work well if you apply them to, you're doing a total of 240. I'm going to do two sides at 120 each, and then we've got to rotate this so that it's not pointing that way. We want to rotate it down, which is going to be just orbit. Turn this. You want to get to 90. It's easiest to type that in. 90 degrees. Nope, we lost it. We'll just get that again. No, I did click on something that I didn't want to click on. Okay, now you can see that is being applied right on that side. So let's go and add it to the other side. We can go back into the force one, leave, and target it at two faces here. Oh, we can do it on both sides, and so we'll make that, yours is going to be 240. So there we go. One force. So that's it for the setting up the force and the constraints. It's going to apply the forces on those sides, and it's not centered. You can work on that, add more faces if you want to get that a little bit more. You can add the straw, but primarily the straw doesn't hold weight. What holds weight is the node, these NDF or Birchnell nodes. Okay, so there we go, and now we are ready to run our simulation. Mesh. So a mesh is something you can play with. There are a bunch of settings in here. You can read about them. It can speed things up. I've just always accepted the defaults. It seems to work pretty well. You can generate your mesh right now. That'll save you some time. And you can see what it looks like. I'm not going to do that now. I'm going to do it all at once when we solve. So you can do a pre-check. Okay. We've got some 23 fully unconstrained groups. Click here to select automatic contacts. Let's try that. It's going to connect things that are within 1/10 of a millimeter. Let's try it. This didn't happen the last time I did this, but I think it did not like the fact that it was an assembly from Onshape and they weren't, everything wasn't mated. Let's pre-check it again, and there we go. That, I think I had an issue in class. That was the issue. I've not seen that before. But now we have a solid model. This saves you the trouble of doing the single part, which causes all kinds of other problems. So if you can avoid it, then you can do it this way. All right, now we're going to go to solve. We finished our pre-check. Here you can generate mesh again. The mesh is a numerical simulation of your bridge loading, so it creates little tiny parts that it compares to each other as you add load. How much load is on this one relative to that one? This is called finite element analysis. It's pretty darn cool. It was one of the first cool things I did in college on a computer. Okay, so we're going to solve this. It should say unlimited here for your credits, education account. If that's not the case, there's some preferences you can change, and we're going to solve this. You may not see these cloud credits. You can show them here. Let's solve it. It is running the solve now. It takes, depending on how complex your model is, between 3 and 5 minutes, maybe longer. So you can see what it's doing if you click here, sending it up. So this is called a cloud solve. It sends it up to their Amazon servers. Probably waits until those servers are available because we're getting free credits. So if everybody's on Amazon or on some website that uses an Amazon server, you're not going to get access to it. So this is going to be running. I'll pause this real quick and we'll come back. All right, it was about 3 minutes or so, and it looks like it is complete. And we'll click OK. It's hiding behind there. And safety factors, we'll talk about those, but this is saying you've got a pretty bad safety factor. I really loaded this little tiny bridge up with your full load on my tiny bridge. So it can show you the weakest area of the design, which is showing right here, the minimum area here. The deformation scale is how much it shows how things are going to kind of bend and move. They don't actually bend. They break before they bend. That's about what it will look like before it breaks. These are really great little tips. Obviously, a bridge, you probably want a higher than 3 times safety factor based on how big the safety factor is. How much more weight will it handle than what you've designed it for? So you design something for the worst case scenario, and then you want it to be able to handle more for that case that you did not think of. So you can hide this automatically, but we'll close it for now. The one we want to look at, stress. Safety factor is interesting. Stress is what you basically saw. We don't quite get the numbers. This is giving you a little bit more more information, but you should see something quite similar. You can change your deformation here. It kind of shows a little bit more. This is, of course, not actual. This is actual based on how much MDF will bend. You can see where that's how much it will move before. Well, we don't know what happens if it breaks or what. But so that's your stress analysis. I'll have the modal analysis in the next video. It's very similar. So let's finish this and see if there's anything else to talk about here. Yeah, this displacement is not really applicable here, but that's which parts are going to move the most. Of course, this is going to move the most. These are all in tension, actually. Stress does not give you tension and compression here, like our other study. It just gives you kind of the forces and how those forces impact these members. So you've got to kind of know that from our other study. All right, we'll do a modal study next. Will tell us how it twists.